All right, hello guys. This is for 9.4. This is the most recent section that we did. We started this on Thursday before we got kicked out because of the coronavirus or whatever. You guys were doing awesome with it, but it's been a while since you may have kind of forgotten. So this was the section where we talked about quadratics that looked like this: ax squared plus bx plus c. So what's different here? Well, the big thing is we have a leading coefficient now other than 1. So there's going to be a number on the x squared. For example, a quadratic that looks like this is 3x squared plus 16x plus 5. So they're going to say, hey, I need you to factor this, and we need to do that same way as before. So we need to figure out what times what gives us this. So you can like sit there and figure out, okay, what goes here, what goes here, what goes here, what goes here. And you could do it the long way, but I'm going to share with you guys a few steps, which you've already seen probably, to make this go much easier, to make it a little bit less work for us. So the first thing that we're going to do, step 1, is we are going to multiply a to the back. So multiply a to the back. And you're probably like, what does that mean? I would be too. We'll talk about it. All right, then after that, step 2, we're going to have a quadratic that looks like last section. So it's just going to be x squared plus something plus something. So we just factor it like normal. We factor it like we did in section 9.3. So factor like normal. Okay, there's our step 2. We're going to have an answer when we're done, but it's going to feel like we're done, but we won't be. So step 3, we have some more stuff we need to do. We now need to undo the damage that we did in part 1. We need to divide back out, whatever that means, by a. And then step 4, if we have fractions in our answer, we need to get rid of them. So we need to destroy all fractions. How? We'll see how. All right, so let's do the example that I wrote down at the top there. So we're going to do the 3x squared, so example. We're going to factor 3x squared plus 16x plus 5. All right, so we're going to follow our steps that we mentioned up above. So same thing as we wrote down. Step 1 says multiply a to the back. So this is my a. I'm going to take and I'm going to multiply it to, well, the back is this number. So I'm going to multiply it times this 5 here and get 15. So after I do that, it's no longer here. I'm just going to have x squared. This plus 16x doesn't change. And then 5 times 3 is 15. So now we have a new polynomial, a new quadratic, and we know how to factor this. We've done it a million times. So I'm going to look for factors of 15 that are both positive. And when I add them up, I get 16. Well, I don't have a ton of options. It has to be 15 times 1 here, because when I do 15 plus 1, I get 16. Okay, sweet. So now I'm going to write my, my two binomials then. So I have 15 and 1, so x plus 15 and x plus 1. Okay, awesome. So now I need to do step 3, which everybody always forgets about. I need to divide back out by a, because if I multiply these two polynomials together, I get this, not this. They wanted me to factor the original, not this one. So I need to fix it so that I actually get this back. So I need to undo this multiplying the 3 to the back. So I need to divide both of these things by 3. Okay, so now step 4 just says destroy all fractions. We did not talk about how. So if you have division that gives you an integer, like 15 divided by 3, we're just going to change that to 5, because 15 divided by 3 is 5. If you have a fraction that does not equal an integer, like 1 over 3, we're actually going to do something different. We're going to take the denominator and we're going to move it out front of the x. So this first one, like I said, I'm just going to change 15 over 3 to 5. Okay, that one's done. This second one, though, I'm going to take and move this 3 in front of the x. So I get 3x. And then I have plus 1 after that. I just keep the other number the same. In this case, it's 1. Okay, here's our answer, and if we multiply it back out, like if we do our double distribution, x, 5, 3x, 1, okay, I get 3x squared, I get 15x, I get 1x, and I get 5. Oh, sure enough, this gives me 3x squared plus 16x plus 5. Awesome, so we got it right. Okay, let's do one more. So we're gonna do, let's see, example. Let's factor 5b squared minus 4b minus 9. Now, do you think that I will be able to maintain these being b's and not turn them into x's? We'll see. Okay, so what was my step 1? I need to multiply a to the back. So I take this 5, multiply it to the 9. Okay, so it's going to be gone. So I have b squared minus 4b minus 9 times 5 is 45. Okay, I am looking for factors of 45 that, or negative 45 rather, that when I add them up give me negative 4. So I don't have a lot of options here. 45, I can do 9 times 5, but I need to make one of them negative. I want them to add up to negative 4, so I'm going to make the 9 negative. Okay, so my factors then are b, look, I'm still using b's, minus 9, and b plus 5. Okay, and am I done? No, because if I multiply these together, I get this, but I actually need to get this. So I need to divide back out by my a. In this case, it was 5. So divide by 5, divide by 5. Okay. So now, if they divide out to an integer, I'm going to change it to an integer. If not, what do I do with the number? I move it out front of the b. So in this case, I get 5b minus, that stays a 9 now. And I get, well, 5 over 5 is 1. So this one is b plus 1. All right, if I multiply that back out, sure enough, I get the original quadratic back. So we are done.